Let's do once more time. Good morning, everyone. Okay. So today's topic is semantic search and intelligent content discovery with embeddings. Before going with that, we'll discuss some ideas about how many people know or what they understand about it, what they know about semantics. So let's start. Who know about what is semantic? Okay. How many know about what is vector? That's nice. That's nice. And how many know what is keyword? कीवर्ड के लिए तो हाथ उठने चाहिए नहीं? कीवर्ड तो पता ही होगा. गूगल पे सर्च करते टाइम व्हाट वी टाइपिंग. सो हाउ मेनी पीपल नो व्हाट इज क्वेरी? सो दोज आर द बेसिक टर्म्स. इसको हम बहुत सिंप्लीफिकेशन में समझेंगे आज. In this particular session, what exactly the semantic search, what is the use, and what's the today's problem, we will discuss around it. So think this way. Since 1990, when we started working with the search, till now we depended on the keyword search. Like what we want to search, we type on the Google and we expect a result. Since 1990, there was a lot of evaluation been happening around it. So keyword search shifting to the intent searching. On this particular topic, we will go in the detail, but that's the overview. So hi everyone, my name is Rajan, and I am a principal architect in the iSpace, also supporting the Comtech for the project discussions. So I did a very good example, an experiment just to explain you what I meant. This is one of the famous websites, and to be honest, I have learned a lot from the Wikipedia already, and I believe everyone is using Wikipedia for long. So how many know about the Wikipedia? Oh, that's nice. So on the Wikipedia, I did a search, best city to live in India. And the result I get it, the best city to live in India does not exist. Now I'm thinking, what's wrong with the search? Wikipedia already have all the information, right? The best living life in the Ahmedabad, the best infra in the Bangalore, everything Wikipedia have. Then what's the gap? We simply asking a human understandable way, like best city to live in India, but the Wikipedia absolutely depend on the exact phase we searching. That's called the keyword search. That's the problem we're facing. And then Google know about this issue for long. So let's understand why this keyword search have the issues. It exactly look for the word we type. Suppose we type for best bat to play cricket in-house. So if the exact phase is not matched, we will not get a result. That problem has to be fixed. It also misses most relevant information. Those are hidden in the internal layers, like we have seen in the Wikipedia example. So we know that the Wikipedia already contained all the information needed, but all those are missing. And the funny one, it says that page does not exist. The problem with the keyword search is it does not understand the meaning, what is user trying to understand or what user trying to want. Like best city can be dependent on healthcare. Some people think best city is where the technology is high. Somebody think best city is where is no less crowded. Everybody have a different meaning, right? In that particular context, the keyword does not understand what the user want. And that's come to the user frustration. Now, I did the exact phase search on Google. Best city to live in India. Now, some difference here. This time, what Google does, based on the context, it figure out set of the cities and also the AI overview that explain based on the different perspective of the person what city is best, and take a decision on the Bangalore is frequently ranked as top city due to its strong IT sector, educational institutes, and vibrant culture, and so on, so on. Now you get the idea. User want to search something, and he's expecting a result. Important part is the intention it should be understandable by the search system. How many people now feeling like, yeah, this is a big improvement we are seeing nowadays. What we want to search, we quickly see that, right? How many of you remember the day when you facing some issue in code and you go on the Stack Overflow and you exactly found the solution, you did a copy paste and it works, right? Because we know that finding the right solution is so hard, and we feel so lucky that we got the quick solution from Stack Overflow, and this is how we feel like. Right? This is the real feeling when somebody is struggling with the code for long, almost a night, and suddenly you get quick solution by just pasting 2 lines, it's done, right? Now, with the search we have seen, why feel like the Google is smarter? It started using the semantic. We will discuss more what is semantic, but the idea, start using semantic and the AI overview, which summarize and tell us that this is something you are looking for. It actually understands what user want, not just the keyword. So if we are searching something, then intention should be clear exactly what is user behavior is and what the exactly user is needed. It also adds additional factors as a layer to simplify your queries and give you the best result. In the search, when we search something, so we have seen that there is a sequential result, right? This is the top result, second, third, and fourth. But how the ranking now happening based on the keyword versus what exactly the user wanted. Those difference has to be there, and that need to be fixed. And also nowadays we have the AI overview which give the summaries to explain everything. Based on our query, like if we search for best city to live, it add more layers on it based on healthcare, based on infra, based on what. So what is top result? Based on it, it can conclude and share. Now let's get back to the point. What is semantic search? Let's back to the basic. How many know about the vector? Okay, great. People who don't know about the vector, I will use the simplest term to explain, okay? If any mathematics student who feel like, that's the stupidest definition we have seen, but those for the people who like simplicity to understand. Any word, any phrase, any sentence, any text we write, we start writing in a mathematical sequential order. Like say hello, so we can write the hello is 2.5, 3.5, or anything, I'm just saying randomly. So there is the additional way to write text in numerical dimensions. That's called the vector, simplest term, okay? Now, semantic search. So what we did is, there's a lot of the text, we convert it to the vector and then store somewhere. And then when we have a question, we also convert that question in the vector and we search that vector in the stored vector database to figure out the nearby result. So how the nearby result calculate? If question is 3 and answer is 4, 5, 6, and 3, what will be the answer? 3. So this is how it find the nearest match based on the question and give the outcome. So the particular process called the semantic search, how the vector is going to be matched, how the return will become, that's called the semantic search. Sorry. Let's start with, again, I'm going in this video absolutely basic so you understand what exactly it is. So we go with the query. So what is query? It's, again, I already explained on the Google, you go and something type, right? This is something you need to know. So I did a query on need doctor for sugar patient in Dwarka tomorrow. That's the query. Now, before we get the answers from the system, we also have to do some work on our queries to make it simplify to understand by the machine. That process called the normalization. So in the normalization process, DR becomes the doctor. We do all the lowercase, remove all the noise like the comma and everything we have. So this is how we make the normalization. Once we have the normalization done, then we do the NER extractions called the name entity recognition. What exactly it is? If you see the sentence here, the sugar patient is like a condition, right? Like a person who is a diabetic. A Dwarka is become the location, and the tomorrow is become the time. So those the definitions called the name entity recognition. So query have all this data. So the solution we are going to figure out from the data, understand this is what something we already have. Based on those parameters, we will get the result. So that's the query. Again, what is embedding? This is the slide I have where we also can simplify this. Embedding nothing, just the representation of the vector. Like we have any text that we can represent in the vector format. So how embedding been stored and how embeddings been connected. Sorry, I'm under weather, so my voice is pretty dumb. We search for a doctor, suppose. Then relation find this way is the nearby connection can be physician or the surgeon. Think like the number. If we search the 4, then nearby can be 2 or 5. This is how it make the connection between database itself. So here it also capture the meanings as well in the embedding. So when the embedding capture the meaning, it also start creating the relation between things. So the doctor and the physician is exactly not the same, but they are relatives. Right? Mama, mama hota hai, poopa, poopa hota hai type. But they are connected. Now, how exactly embedding going to be functional here? In the embeddings, when we need to create the embeddings, what we're going to do is we are going to create the embeddings, we need a module. So either we can create the module or we can consume the existing module, but here the question is to understand how the embedding is going to be functional with the modules. So in the embedding, suppose we select a module called bird. Now, how text is going to store or how text is going to be converted as the embedding. So suppose we have a text that called the dimension. Say hello. That is breakdown in the 12 tokens. And those tokens is stored as 768 dimensions differently in the database. This is how data is stored in the vector databases. So actually when we use a module, and from text to generate the embedding, it produces a dense vector. So dense vector is the multi-dimensional. Multi-dimensional, just imagine the 2D table for now. It's actually, there is more dimensions, but understand the 2D table. This is how it's stored. And then we also do a keyword spares. So what exactly here is? The doctor goes with a 2, Dwarka is 1, patient is 0, apple 0 is more about the number of the keyword being repeated in the system. So the doctor in the Dwarka, if we go, just to understand, so doctor goes with the 2 words, Dwarka is 1, patient we don't have any value, and the apple have no values over there. So the summary we discussed here is, in the embeddings we convert word, sentence, document into numeric vectors, although we also can convert the videos and the text as well. The goal here is to capture the meaning context and relationship beyond keywords and enable machines to understand similarity and semantic. Example I already explained, like doctor and physician have embeddings, they are closed. Now, what is vector database? We created a vector. It is the multi-dimensional setup. Now, the problem is how we're going to hold that vector somewhere so we can do a search, because query need a place where it go and figure out something, right? So how many know about the database already? Any? That's great. That's great. So most of the people know about the database, right? So the vector database is similar type the database like relation, non-relation you have seen. It just not store in in the table structure. It's stored in the dimensional structure. It have its own strategy to store it, but it is not the table-wide structure. So here, it able to convert text, image, audio, video, and convert to the vectors and store. So by using those modules, you can see here, we convert all those things into the vector, and then we have the vertex AI, quadrant, or waveite, chroma, files, all those kind of the database available. We store all the vectors over there. And there is some strategies how we should store the data in the vector database. That called the indexing. People who know about database like know indexing? Anyone know indexing? Okay, I will simplify. Indexing is how many have created the index when they go in, the presentation or in the college or somewhere. This is the first, second, third. Create a relation with that for now, right? So indexation is how efficient we writing where is where stored. Like we have about a science project or page number 14. This is how we done the indexation over there. So indexation help to figure out the strategy how we storing the data in the database. So it have multiple modules going on, but those are the simplest one. You can learn about it. As I said, I will keep it basic. So how actually the database works here? We know the query, right? Now we have the embeddings available. As soon as it comes to the vector database, so what we did is we created the indexations over there by using some strategies, HNSW, mostly IVF with that, and the PQ. So we simplified that filtering first. So cities become the Dwarka, specialty become the, what did I write? Okay, diabetologist is the specialty of the doctor. So that filtering we are going to store with the indexation database. And then ANN is going to be work with that. Now, what is the top K candidates here? So we stored some values in the database. Now when we search something, the query will produce some result based on the nearby search. So those result is the how many result we would like to see, number of 3, 4, 5, 7, 10. So those are the result, the top K candidates we have. So we place here the scoring and re-rank. The scoring is give the number, like this is good, it will go first, this is less than good, it will go second, and so on. And then re-ranking also rearranged in case we have some additional manipulation is coming based on the additional layer of filtering layer. So that rearrangement is going to be there even though after there's a filtration is done. So first we create the scoring, this is the number it will be have, and then we will re-rank that. People know the sorting. How many people know the sorting? So this is kind of the concept. Scoring plus re-rank is like a sorting. So once we have the result, this is how vector database is going to handle those. So the vector database have the specialization in embeddings, as I said. It just store the vectors value over there is simplest database, and it enable the similarity search. Find closest meaning, not the keyword, not the word. It just find the relations. The goal here is to follow the efficient indexing because search need to be fast, right? We don't want to look for a city for at least 10 years, right? So efficiency is important here. So algorithm like HNSW will help to make the indexing fast, so it produce the good result. It should be scalable, and the multi-module is very needed here because scalability is the key, because vector database is growing so fast. As more as we going to create the indexation, it becoming big, and we need a way to make it scalable. So one of the open source maybe you can try is FICE. Otherwise, there's more. Pinecone we have, Wavetide we have, Multivast we have. PG Vector is one of very known for the work. And then, so with the embedding and the vector database, we push a query, embedding generated. We have the vector database that produce the query result, and we have the result. But still, that result need to be simplified for a human. So what happening here is, after the database created the result, we simplifying the result. So we search for a doctor in the Dwarka. So we get a doctor list, 3 doctor lists. You see here? So this is how the database produce a result to us. Then we feed that result to the LLM, and then LLM is produce a human understandable format for us, which is based on the context. Here are the doctors in the Dwarka who can treat diabetes or sugar patients. This is how we have. So we search for the sugar patients, and system understand this is related to the diabetes and figure out the doctor for that and produce the result, and by through the LLM we have the result here. So this is the strategy we had discussed. The architecture of the semantic search plus LLM we have discussed. So it's divided in 4 steps. One is the query. Again, I'm just recalling what we have discussed. The query to the embedding, what we want to search, we convert it to the embedding. And then we have the database, vector database search, which figure out the top result from based on the query. And then after the retrieval, we have the outcome from the database, and we using the LLM response to simplify the outcome we have. This is the full. If you want, you can just take a picture of this. All right. So I created a quick demo to show you about the discussion. Before the demo, I will explain you. So what you have seen here is the basic strategies followed by all the chat application you have seen. This is the basic idea. So every time you wonder like how ChatGPT works, how Gemini is functional, and how other module is doing. That simplicity is, if you understand this, you can make any website, any application to make it understandable and follow the embeddings. So once you have the embedding in your system, it understands the meaning, not the keyword. And your application you are developing, which will be more human understandable, so user will start loving it like we love the Google. Voice.
Search, we need 3 major components, and
one second, let me make sure the quality is high.
those are the semantic transforms that give us the powerful text embedding models. FICE, which is the super fast vector search library built by the Facebook AI, and then the NumPy, Pandas, scikit-learn. Those are the standard data science library tool we have. So those command install and upgrade everything, so our environment is clean and ready. So we have the environment up and functional. Now next is every semantic search system start with data. For Ahmedabad DevFest, I have created a fresh dataset based on real doctors, information available on internet. So we manually seed some realistic question answers pair, and then I expand the database programmatically. So it takes 10 major cities, I mean the Ahmedabad areas, and then the specialty that combines here. By the programmatically, I generate around 100 question answer of set as a record, and then I pre-process the questions by lowercase, remove punctuation, so the model sees clean text. So let me show you that. Here's the first five high quality records we see here. So this is the first five records. Next, what we're gonna do is,
I'm stopping here. Till now, do you understand what we have done? Right. I will again simplify who never nod the head. First, we just installed the library and we, created a data set which have the question answers about the Ahmedabad cities and nearby results. Right? Nothing else. And those are the 5 just results which I stored in the upper one.
we are going actually to do a magic. So here's the magic begins. Semantic search works on embeddings and numerical vectors that represent meaning. So here I load the all mini LM L6V2 module, that is embedding module. So it lightweight, fast, and one of the best semantic similarity tool we see here. Then we do the pre-processed text, and then and convert all the questions into embeddings, and then create index using the FICE vector based, and then install all the embeddings into the index. In this step, we consuming all the questions answer set we have created in the past and convert it to the embedding. That's the main goal we are doing in this particular section. So once we trigger this, that small module is going to create the number of the embeddings using the system. So we have total number of embeddings in the index is 100. Next is, as now we have the index ready, then we will run our first query against that embedding, which is, let's take the example, I have a cold, suggest me a doctor. Now, based on the question answer of set we have seen in the past and convert it to the embedding, here the question we have, the first we convert that questions into the embedding, and then we do a search that figure out that going to ask for top 3 similar vectors and retrieve the most relevant answers. And we see here is the 3 most relevant answers in the search. So the first biggest achievement we have after converting to the embedding is, I have cold, suggest me a doctor, and there is a number of list in doctors. Now, good part, how it is different. The question we see here, I have a cold, suggest me a doctor. It's never we have mentioned somewhere a doctor for the cold. It's the embedding who figure out the meaning of the word and came up with the solution. So this is the answer we have here. Next, what we are going to do is we will now this is very search result from the database. So we will take a help of LLM, and then we will take help for Gemini 2.5 Flash. By using this module, we will force module to use only the given context, no hallucinations and no external information. So the output is 100% dependent on these outcome we get from the query. But this time, by taking the help of the LLM, we are simplifying the response, human understandable response. So LLM responded. Before, with the embedding, we have three best match, and then we feed those match to the LLM, and here's the LLM response. I'm sorry to hear you have a cold. Based on the information I have, you should consult a general physician. You can find general physician is Prahlad Nagar and so on, so on, so. So it mentioned all the locations, the possible locations we have in the database, and conclude and provide the meaningful context. So this is how we consume the embeddings and produce a functional LLM, and we can also quickly build a UI that actually looks like something we can consume as a UI. So here we are using a tool Gradio. Here we are not doing nothing different. It's just the process we have done of feed LLM the response, we doing the same through the UI. It produces a URL here. This is the query output we also see on the same screen. Let me open the app in the next tab. So I will search something that maybe sometime I feel like I am, why I remember Hulk, I am angry all the time. Okay, so I understand you are feeling angry often. Based on the information I have, you might consider consulting a psychiatrist for the mental health, stress, and anxiety treatment, and so on. So this is the foundation of intelligent content discovery, and the same approach powers modern AI assistant and enterprise search engine. Thank you, JDG Ahmedabad. Before we build semantic search, we need
So that's about the embeddings. Now let's go with the question answers. Anyone have any questions? किस किस को समझ में नहीं आया? यहाँ से शुरू करते हैं.
Any questions?
हाँ.
When you're creating the search thing, there I saw that there's this named entity recognition. Can you just like explain some of it? Like what is it exactly?
So the entity recognitions, again we discuss about the place, location, things. So recognitions like how we recognize other. This is my pen, this is a thing, this is a time where I have to be there. This is called the entity recognitions. Any, is that, do you understand now? That's all? Okay, anyone?
Yeah.
Yeah. So please go on. I will take you next.
How vector database can re-rank? Can you explain this?
How?
In your slide, we can see there you mentioned the vector database re-rank and scoring. I know how it can score, but I not understand how it can re-rank our results.
So
Or should we use any other models for re-rank?
yes, we can use, there's a lot of modules available, but let's understand the re-ranking. So re-ranking in the simplest way, what is the nearby? That's all it does. Yeah, it's scoring based on the how near it is. So suppose, let me explain you that. So you want to go out with your friend, just friend, you don't matter who it is. So what you will do? You will find the nearest one, right? And the available, both important, right? So this is how the search works. You find your friend, who is the nearby, who can approach me now, and available. So all those values, when it's matched, it start doing the scoring. Like you have a close friend, start with the rank 1, but is not in the Ahmedabad, rank removed. There's a new friend came up in the picture, who is available, who is right. This is how the scoring works. Anyone else?
Hi, so my name is Darwin. I just wanted to understand that we have tools like Cursor, we have tools like VS Code, and we have seen that we share the entire file for context, right? And I've also heard that Cursor uses like you can embed your entire code base to it sometimes. So how, because the example that you showed us, we did a pretty small amount of chunk over there, right? But if it is a something like 2, 3 files that we need to embed, what is the strategy we should use and how we should go forward to it so that the retrieval mechanism is more faster and more accurate?
Right. So this is the bit of the next advanced level of understanding how we can do a best practice on the embeddings. So in this one, we created small chunks. But later on, we can split out the work in the different modules. The one word module will take care of how we are going to simplifying, because simplification is important. You know, normalization is required. So normalizing, converting those normalizations in a different chunk as a summary and then submit to the system. And then we create the embedding. Of course, there will be multiple modules may be required, or you can build your own. But yes, that is possible. But again, that's again, the concept will be same. It's just how repetitive work we have to do here.
So thank you, but I have one more question on the re-ranking that we were just going through. So when we are re-ranking, let's say based on, so basically let's say if I'm creating a chat application, I also want to incorporate the user feedback to it. That if I have someone has asked a query and if they have given a answer, if the LLM has given us an answer in a structured format, if a user says that no, this was not a proper answer, I need some other answer. So I want to take that as a feedback and make sure that I'm ranking it again, or what should be done so that it takes that feedback and react to that feedback the next time the user is asking the question.
So if it is the personalized one, then the user is boss. Whatever he say is right, we store in the memory, and next time it asks, we give the result. But if you need the accuracy and the validation against the feedback he is giving and the actuality, then again this is the process same. You have the validation checker which validate the feedback and give the validation to the user.
So where do we set the validation feedback? Because that's where I was a bit confused, because the process we shown right now is like embedding, okay, we got it, but where does the feedback loop comes into the picture? Where do we ingest those feedbacks?
So the user giving you a feedback is again a query.
Okay.
So think this way, the query came in the picture and they again follow this similar procedure.
Okay, so you just embed it and keep it in the vector
Right,
DB.
right. Then all the meaning of the embedding is just make everything embedding and do a comparison.
Okay. And by the time period, the vector DB would also grow, right? So how do we also take that into consideration, that because slowly and steadily, because if you see Google right now or Gemini or ChatGPT, the output time is very less. So how do we make sure that that output time also don't increases going forward, right? Because there will be more people using it, more feedback coming in, more embedding that will happen. There will be more data that will be stored in vector DB.
Right, so that's the infrastructure cost actually. It's scaling, of course.
Yeah.
So if the resources is consumed, you have to be a money man and make it grow.
Okay. Is there any document or something that you can suggest where I can go through all this?
Yes, I will do one thing. Just connect with me and everyone,
Sure.
and just drop me a message, and I will share the code with you so you can play with that.
Sure. Thank you so
Thank
much.
you.
Yeah.
Okay.
We have couple of more queries.
Hey, good afternoon.
Good afternoon.
So, I mean, how semantic search is different than similarity search?
Similarity and semantic. Okay, so let's understand what do you know about the similarity. Let's start with that. Do you know what is the similarity?
Actually, I don't have clear idea about that.
Okay,
That's why I'm asking.
so let's understand. Never get confused based on the general ideation of the programming. Similarity is look similar. So similarity is the part of the semantic, and the semantic is the process to store the the vector in the system and make it functional. The similarity is the way we do the query, like 3 near to the 5 or 6 or the 7. That's the similarity we have. So similarity indexation we do triggered through the embedding. Okay. कितने लोग हैं जो चैट जीपीटी करके क्वेश्चन कर रहे हैं या करना चाहते हैं, दिमाग में आती है ना? I mean that's not the topic of this one, but I'm saying something. So AI is good, right? That was the one of the speech I just had tomorrow in the Hyderabad. AI is good, but use only when you need it. That I always say that. Okay, that's just a question mark over there on that specific thought. Anyone have any other questions? Yeah, please.
Hello. Sir, actually, what is a fundamental difference between Elasticsearch and the vector search? And in which use case we have to use Elasticsearch, and in which use case we have to use vector search?
So again, Elasticsearch also have the component to handle the embedding. One thing is, again, the Elasticsearch still create the relation, but based on the text, not be based on the vector. But it can be enhanced. The Elasticsearch have nowadays the vector extensions available, so it works. Those are the different tools, but they can be combined and work.
Okay. Thank you.
Sir, I have two questions. What is the maximum, ChromaDB or any vector database? What is the maximum token size it can take?
Token size.
For example, there is a PDF file with 5 to 6 pages, and there is a PDF file with more than 1,000 pages. So, what is the ultimately they store it in indexes and metadata form. So, what best quality it can give for the maximum data set? And in case if RAG fails, what is the alternative solution?
Mostly in my job, I charge for that question, but I will give you free. So this is the more about how we're designing the system. The quality needs to be separated by the chunks and the overlap. So the overlap and the size of the chunk and the quantity we are consuming here, based on that we produce this. Again, this is the combination of infra plus number of the chunks we're producing and the overlap with the chunks. That is produce the good quality of the outcome we needed. And there's more practice going on, but yes, that's something you can find easily on the all readable sources.
So if you are building a product, if you are building a product on RAG and
building a product on
RAG system, if you are building any product, and at the end, if you are not getting the expected output, okay, and which, for example, everything we have tried and RAG is not working for you. So what is the alternate solution for that?
So the alternate can be more. So let me rephrase your question. So you are saying that if the system you're building it not producing the result you are expecting, then of course can be some possible issues. One is the module selection we have right or not for the embedding. Then the chunks we are creating and the relation stored in the database and the query we generating the embedding, the chunks is, comparison is right or not. So it's more about the comparison we're doing through the database. So that's one part of the practice.
Fine-tuning LLM is the alternate solution?
In the particular scope, we're using the LLM for the response only. Like the result we have, we never deliver the SQL query to the end client, right? So LLM is just helping us to, simplifying that query to a human understandable.